Colby Davy. This is Christine, and here's my lovely video assignment. First, I'm just going to talk through the mechanism. So I had number 2. The first thing that we're going to do is we're going to take this base and we're going to protonate it. And by protonating it, we give the electrons to the alpha carbon, which was indicated here because this is our enolate and this is our carbonyl that we're using. So we're going to draw out that enolate as is and just recognize that we only have one H here, and we have these electrons in this negative bond, this negative charge at this at the alpha carbon. So then we're going to look at the carbonyl. Carbonyl enolate, just making sure I said that right. And we are going to attach to the important carbon, and the important carbon is going to kick up its double bond onto this oxygen. So now we have this sort of tetrahedral shape here. We still have all of the enolate, and up here is what we got from our carbonyl. So what we're going to do now is we have, from this step over here, we have H2O, and we're going to, again, protonate, in this step 3, the oxygen, and then we're going to end up with OH here and OH here. And normally I would want to grab the H up here for step 4. Just from what we've done before. That's not what we're doing because we want to deprotonate, again, the alpha carbon. And if we deprotonated this, we would just be basically exactly going back a step. So by doing this, we're going to make H2O again, and then we're moving these electrons on to the alpha carbon again. Okay, so by kicking these electrons into a double bond between the alpha carbon and the important carbon, we then, although OH is a bad leaving group, this causes it to get kicked off, and we end up with the final product here with a double bond between the alpha carbon and the important carbon. We have our hydrogen here from the important carbon and our phenyl group that I indicated with a pH. That is the 5-step mechanism. Okay, so for the other products, we're talking here about the self-condensation product, and this is with 2 of the carbonyls because you can't self-condensate with the enolate here because we do not have an alpha carbon. So you're just combining so this is the normal enolate here, just drawn out. And then this is the important carbon that's attached here. We lose this double bonded O in this for the second molecule. In turn, we create a double bond again between the important carbon and the alpha carbon. And since this is a ketone, we don't have to worry about self-condensation here. This is an aldehyde. Erase that. But we're not worried about self-condensation here. And we are there with our enolate, not our carbonyl. Sorry, I had to walk that back. And then we add it slowly because the aldehyde that we have, again, right here over the arrow, can play, as we've seen here, with the self-condensation, and as we've seen here, it can play both roles, enolate or carbonyl. It can be an acceptor and a donor, and we don't want this to happen in this situation. So yeah, that is my video assignment. Thanks so much.